Hello everybody, welcome to another stream. How's it going? What's that over there? Okay. Right. Last stream was fixing a reordering bug in the ray tracing, so since they are not spheres anymore, the whole sorting front to back per tile, per screen tile that we render, wasn't working well. Let me disable the occlusion culling because it's broken at the moment. So now if you look at these ellipsoids, they are now kind of sorted front to back per pixel as well, so they show up in the proper order and they don't get rendered out of order. But this is only for the ray trace anti-aliasing shader. We want to sort out the super sampled anti-aliasing and the multi-sampled anti-aliasing shader today, and then hopefully fix this occlusion buffer bug where things are occluding which shouldn't do. And I think I know what a problem is, but maybe there might be another one. Yeah, so hopefully get all those things done today. So if we go and actually change over to the one of them, so we'll go to the multi-sample anti-aliasing shader. We will see that there is a clear, or it is clearly different, right? So one is a lot slower. To see here, it's not poking through the top anymore. This one here is not poking through the top. And when you move, the ordering changes, and that's because they're ellipsoids, so you can't sort them front to back per tile. When things overlap, they can you don't know what is in front unless you sort it front to back per pixel. So we're still sorting it front to back per tile in our sorting pass. Wow, this is dramatically slower, but there we go. In our tile binning process, we are still sorting front to back. Or we sort them into tiles and front to back at the same time. But in the pixel shader, we sort every hit. So this is what the change is. So we still use the sorted front to back per tile as an optimization to sort a very, to early out our hits basically. But we build up a small hit list of about up to 4 hits. So we've got like three layers of transparency if you've got one opaque, or 4 layers of transparency if there's no opaque hits. And then we sort those hits front to back very quickly in the pixel shader because it's just 4 things we need to sort per pixel. And then that just does the job. So we're just going to do that for the MSAA one now. So I think we're on, I don't know what we're on, but it's about 7 milliseconds for this MSAA one, but it does nice AA though all around. It's better than the ray trace anti-aliasing, that's for sure. So we hop into the shaders.c file. We're going to hop to the MSAA shader. And you know, it's probably better if we start on the super sampled anti-aliasing one, because that one is a lot more simple. It's basically the same thing, except for the MSAA is a optimization where you only sample the same object once. So if you have subpixels hit the same object, you only sample it once, material once, whereas subsample and it does it properly. I guess there's a better way of just saying it. So you have your, say if you have MSAA times 2, which gives you 4 subpixels for a single pixel. If you have like an object, like a sphere or something, or an ellipsoid like this, with these 4 pixels, we'll hit this. Either only sample this once, but through the ray of the pixel in the middle, right? Whereas super sampled anti-aliasing would just be like as if we rendered upscaled, and then like just down sampled it, right? So it just takes the average. So this is why the super sampled anti-aliasing is cheaper, because it's simpler but more expensive, because it's just a for loop doing 4 times the amount of work or more in the shader directly. So we'll go and start on that one because it'll be easier. Hey Temvar. Yeah, it's just a nice little program that works on Windows and Linux as well. My only downside with it is on Linux, since I've upgraded to a 4K monitor, is that it doesn't DPI scale like it does on Windows. So yeah, it's a bit of a problem, which is a shame. But other than that, it's a really cool program. I like it. I can still interact with the UI. It's just shortcut keys. Using shortcut keys. Yeah, how's things going? How's your weekend? But yeah, the thing I like about Milton is just like an infinite canvas. Another problem about it is there's not infinite zoom, but I guess you can just zoom out enough, and then you're alright. So, oh yeah. Wait, so what was the MSAA one? Was that ×4 or something? Okay, it's only ×4. Right, so right now I don't have it passed into the shader, it's just a constant. But I haven't bothered doing it. Yeah. Setting that up for some reason. Samples count is that squared. Hit list capacity 4, perfect. This is what we want. So effectively the way the shader works is you get array origin, and then you just do a for loop per subpixel. And you just calculate the ray direction for each subpixel, and you just go over all of the ellipsoids, where this generates the hit list of all the hits that you find. And then you do all the shading for all the hits that you find in a front to back manner. And then you accumulate the final color by taking the subsample color that you've got, and doing that for each subpixel. Then at the end, just divide and compute the mean, right? The average. So it's a very simple shader in that regard, but we've got to make it a bit more complicated by adding that sorting, because this is technically not looping over in a front to back manner. It's a rough front to back order, because we're using ellipsoids basically, and not spheres. So if we go to the RTAA, the ray trace anti-aliasing, we're going to steal some code from last stream and get the ball rolling. So we probably need, you probably want this opaque hit index and opaque hit far. These help to do optimizations of earlying out. Then you need this B box near hit. We'll go over this in just a second. So when we do our sorting front to back per tile, we take the bounding box of the ellipsoid and got the near depth. So I fished that out of the sorting array, and it's used as a way to early out. It was the only way which worked. It's the only metric we can use which worked. And then there's this insert code here into the hit lists. Oh crap. That doesn't go there. It goes on the hit. That. New. So I'll just copy over all the code and then we'll go over it. Okay. And this is the final bit I guess, while we do the sorting, we only need to sort 4 elements. So yeah, we just sort those with a very focused sorting algorithm, I guess, for 4 elements only. So we only have 3 layers of transparency with 1 opaque hit, or 4 layers of transparency with no opaque hit. So there's a few little things we need to change, like fetching the index from the sort hit list. And then I think we need to initialize all of the right, subsample down here, looking good. So down here, the for loop needs to change. We'll get it from the sort list instead. And then we need to instantiate all of our hit depths with infinity. Is that packed? Oh no, it's not. Okay, sorry. I thought it was an integer. It's a float. I was reading the wrong line. Right, infinity. Right, here we go. Weekend is good. Been toying around with building a 2D platform. Awesome. What's the idea behind rendering these ellipsoids? Are they bounding geometry for Raymarch thing, or are they actual geometry, game geometry? Yeah. Okay, they're going to be game geometry. It's just, you don't see many renderers. There has been like a game in the past that's done ellipsoids, but I haven't really seen many games do it since that game. I only learned about it when I started doing rendering with spheres. Someone mentioned it, someone did it with ellipsoids. And then I was like, you know what, ellipsoids will give me more flexibility and for getting a different look. So I moved to ellipsoids. So yeah, it's mainly just sort of to have a sort of unique looking game, but we're still in PBR. And I think I've recently been thinking about, because I want to move back to the editors, and I was sort of rushing off the material editor just to get onto the model editor. And I was thinking, you know what? I want to think about this material stuff. How do I want to do it? And I've thought about how I want to do it now. And probably just because I chatted with Russ Musco about it, so a viewer on the channel, and he's in the Discord, and he was saying he uses procedural texturing and does it at runtime. But yeah, I don't think I can manage to pull it off at runtime, just with the complexities of my shaders. But also, I think maybe bitmaps might not look too great as well. So you'd need bitmaps to make things look good at varying sizes, I think. Maybe. So I was thinking maybe the part of the editor is you just basically have custom shaders that generate materials, and you can have sliders and stuff into those custom shaders, and you can make your own materials as and everything. So it'd be proper cool, and it just compiles out to a texture. So I've been thinking about that, and all the different sort of PBR maps, texture maps that I'll need, which ones I'll need. So I think about when I've got my next thing, sort of off-stream thing that I'm doing in the background done, I might move on to writing up that plan. I'm currently working on a settings. Can I run the game without? I can. I'm currently working on a settings search dialogue thing. It's pretty cool. It's coming together well. So right now I've just got some testing on anti-aliasing. Because the problem it's trying to solve is right now how I change stuff. Let's just move out the way of that glitchy thing. Is that I change something in code to true or whatever. I change some option, and then I recompile the game and run it, and then I can see a different mode of something. I need to get some settings in where we can quickly change some variables in the system, and this is what it's for, and it will save that to a file as well and remember where you were. So I've just been doing this sort of fuzzy find thing where you can sort of like, these are all declared using the encoder system. And I'd literally just pop in a new line in a structure type definition. And it, depending on the type, it will populate this right hand side with the right ways to change the value. And I'm thinking about making it such that you can search for your thing and you can press a button and it will sort of like fold all of the UI away except for the setting you want to change, and it sort of just put it at the top of the screen or something, and you can sort of like just change the setting live while you're viewing the whole game type of thing. And yeah, this fuzzy fine's also on the options as well, so it's quite nice. But yeah, this thing I'm currently trying to work on, it's only got support for enums at the moment, but I'll do integers and floats before I call it done. Yeah, it's going to be proper handy. And then after that, I think I'll work on this sort of write-up plan for materials and stuff, so we can make these ellipsoids look like, you know, how are we going to make these ellipsoids look more than just these sort of rounded things? Because if you have like a normal map that's generated through custom a procedure generated material in code, then you could just do, you know, you could make these things look boxy if you wanted to. You make these things look cylindrical if you wanted to. Well, what's the word of like a cylinder that's not a sphere? It's like I don't know. But anyway, you could do stuff like that, and it could help with not just making things out of ellipsoids that look very bubbly, but you could always do that if you wanted to. So the flexibility is there to achieve such a look if we needed to. Yeah, it's a thing I've been needing, that is for sure. I was thinking I needed like a console thing as to be part of it, but I was thinking about that and I was like, well, just having it do settings is fine. Then having if I want a console one, I can make that separately. But that's gonna be really handy. So I can switch between the super sampled anti-aliasing shader, multi-sampled, and the ray tracing one just within a few clicks. You know, press enter or something and then just use the arrow keys, and so it's gonna be ideal. Oh, all the drinks by my hands right now. All the drinks. Right, so super sampled anti-aliasing. It's just a for loop over all the subsamples. Yeah, your subsample coordinate. And yeah, get the ray going through that pixel. Accumulated alpha. So this is the new thing that we've got to figure out, is like, right, so they've got the E indices. Okay. So yeah, this generates the hit list. I wonder whether or not we should take the yes, this is essentially rasterize the ellipsoids. Now you can't early out with accumulate alpha anymore. That is something that we'll have to do later, because these are sorted front to back, but they're roughly sorted front to back now that we've realized this. So the accumulated alpha thing has to be done when you do the material processing of the hit lists after it's been properly sorted per pixel. So we'll take that stuff out. And no longer will it be accumulated alpha. It'll be based on the subsample color or something. Actually, yeah. The subsample color .a is greater than 1, then we break, so you don't have to keep shading unnecessary pixels. Cool. Right, so rasterize the ellipsoids, find all the ellipsoids we hit and generate a hit list. Right, this is slightly out of order. So ray versus ellipsoid. This is checking. Yeah, we found out a way to early out. If you don't need to check any more ellipsoids, basically, because you've hit something which is opaque, and you've stepped far enough that you definitely wouldn't have hit another thing which is overlapping. So I think the idea is like, yeah, I think this was the figure we looked top down on our scene and had this sort of thing happening and drew it. So the ray comes from this direction. And these are the three ellipsoids here. What this code is doing is, so we have a bounding box in view space that things are sorted by front to back. So if the rays coming from that way, view space is probably, well, it really just depends because this has got a field of view. So let's say it's this way just to keep things more simple. So these all have these sorts of bounding boxes. And then nearest Z would be this edge here. Right, so that's the B box near depth, is these edges of the bounding boxes. So what happens is, how do you know if I hit this one, say if they're sorted in this order, where it's 1, 2, and then wait, 1, 2, then 3 or something like that. Yeah. So when you hit this ellipsoid first, we jot it down as an opaque hit, and we say it's T far, so when it exits, this ellipsoid is here. So we jot that down. Now, how do we know whether this ellipsoid that we're going to do a test next is far enough to the point where it's not overlapping this one? Well, the metric that we're using is the near depth of the bounding box. So the near depth of the bounding box, remember in view space, is this edge here. So it's just that Z coordinate basically. And we say if this Z coordinate is further, what are we saying exactly? Yeah, we're saying, yeah, if this near is further than this point, so I guess you're saying it along this ray, right? So if this near is greater than this far, then we're checking a hit which is not overlapping with this opaque hit, shall we say. So if you've got some which are overlapping, they will be sorted roughly together, and ones which are sort of further back. There might be some glitches, though. I can imagine there can be some glitches. Maybe we'll have to change the metric. You might have something like sitting like this, and you put a bounding box around it, and its T near is here on the bounding box, which puts it there, and here's the exit point. So technically here it would end, but it would be safe for this one because the ray actually hits this one first. But what happens if this was the first one it hit, and then this one? Yeah, it's all just a luck of how things are sorted. So maybe we might encounter some glitches. So in which case we might tweak these values a little bit, like multiply them or something, just scale them a bit, which will make performance a little bit worse, but it's still an optimization. So that's how we managed early out. So what we used to do is just append onto the hit list, but now we've got to be a little bit smarter about it. So we're saying if it's actually transparent, our insert index is the end of the hit list that we've currently got. We only support up to 4, remember? 3 opaques 3 transparent ones with 1 opaque, or we have 4 transparent ones. So this is how this code handles all those situations. So if it's transparent, we just say, well, the insert index will be at the end of the list. And if it's not transparent, we go, right, if we've not found an opaque hit yet, we will overwrite the last entry in the array if it's full by taking this min operation. If not, we'll insert it at the end of the array if it's not full. Then we say the opaque hit index is wherever it's been inserted, and the opaque hit far is tfar. So we hit another, and then if we already have hit an opaque, what we do instead is we say, right, if this hit is nearer than the other one, then we shuffle around our t hit far thing, and the insert indexes, we overwrite that opaque hit. So this handles all those cases. And then if our insert index is actually in bounds of the 4 item list, or sorry, the 4 element array, we up the element count if it's not the end of the array. Sorry, we up the element count if it is at the end of the array. Then we insert into the hit list. I called this one E indices because it doesn't store the alpha in there. Why would I put the alpha in there? Oh, because of the near miss on the ray trace anti-aliasing uses a near sort of miss thing. Right, I see. It does a near miss thing with its to do anti-aliasing, and then carries on if it's a near miss, and sort of fudges with the alpha. So yeah, let's change that a tiny bit there. So we put in the full-on ellipsoid indice into that one there. Cool. So I think that's all looking good. Just forgot to delete the old code. Now this is where the magic happens, where we do the sorting. So we saw the hit list. That is so that it is definitely front to back for this pixel, as the front to back view space bounding box sorting is not 100% correct. So we've got some ways where we can maybe make this better, but yeah, effectively we're just doing a hand-coded sort for elements. Yeah, maybe we could make this like a ternary operator, and maybe that this could end up being a just a select instruction, like 5 select instructions, maybe. Let me write that down. Maybe we can we just make this a ternary operator? Yeah. Ternary. It's ternary, isn't it? I think so. I always get confused with these things. Ternary. Oh my days. Second guessing myself. Just make this a ternary operator, which should hopefully compile down to a select instruction. So yeah. Anyway, that's when we bother optimizing any further. It's good enough for now. We looked at it for well, we've still got to test tons of instances and stuff, but when we had like a full screen worth of ellipsoids with like 25 checks per pixel, it was coming out on a 1080p screen on a mid-tier card, which this is. So we actually on a 4K screen, but shrink it down to a 1080p window. And it was about 2 milliseconds, so it's looking good so far. So yeah, that's looking alright. We keep track of the normals, right? No. Why don't we keep track of the normals? What do we... Oh yeah, because we're not calculating the normal in this one. You do for the RTAA because it uses the normal as the way to check if it's near the edge of the ellipsoid. Cool. Right, then when we do our... Now this is where we do our material sampling. So we go over... After we've sorted based on the depth per pixel, we've got an indirection buffer basically. Pass in an index and get this proper sorted hit list. And then take our hit index and just do everything with that. And I think that should just work the same as it used to. Does the shading, does the material shading. Blend the pixels front to back. If the alpha is, if we reach fully opaque, we just stop there, right? If we didn't reach fully opaque, then we sample from the cube map texture, you know, the lovely PNG image. And then yeah, do we want the transparent front or do we want the opaque hit back? So I did do the opaque. Yeah, so I actually changed it such that we render an opaque depth buffer out rather than a transparent depth buffer. So yeah, rather than rendering that frontmost transparent object as the depth hit, I actually did the, where was it? Yeah, so this was the, so when we reach an opaque hit in the blending stage, that will end up being the closest hits. It's actually even better. Yeah, that's quite clever actually. So closest hit T. Infinity. So yeah, when we hit something that's fully opaque, we'll take out the hit list depths. And then that's the thing we'll throw out to the depth buffer. Hang on a minute. Subsample hit T. Now I want to rename these variables because they're not really closest hit. It's really annoying. These ones are just hit. It's just, I copied it from when I did some other ray tracer and I just didn't rename these, so they get them renamed here. Right, so I think that's everything we need to do to fix up the SSAA ray tracer. So let's see if they are sorted front to back properly. And if we haven't... Oh, wait, that's not going to recompile, is it? Recompile and run, please. Right, we haven't fished out the alpha. I think that is because it comes from the E. Ellipsoid alpha. What is that? Right, hit lists, cap, hit list cap. Entries capacity, let's just be more... Just be better with the naming there. So I think I did it in the ray trace anti-aliasing as well. Let's rename that to RTAA hit list entries cap. That's interesting. Are those hard coded to 4 in the super sampled anti-aliasing one? Oh no, they are here. Oh, I didn't change those as well. hit list entries. Cool. There we go. So hopefully that compiles. Oh no. What did you change it to? Damn. Oh. Whoops. SS. So I was thinking that was in the ray trace anti-aliasing shader, but it was in the SSA one. Weird. Right. So we zoom out. Let's disable that occlusion buffer. It's got it hard-coded to the U key at the moment because my settings panel is currently in development and not ready for use, but this would just be a nice way to do it later on. But yeah, it's really really laggy, but it seems to be working. We bring up the performance. 24 milliseconds to do 4 subsamples per pixel, which is to be expected, right? It's a mid-tier card. This is an in-between between 4K and 1080p. It's not going to be the fastest renderer, but it will look good. If I take a screenshot right now, it'll take a few seconds because it's 4K, and I do it on the I do a copy on the CPU like a melon. But there we go. But if you look at these, nice. Even remember these were kind of jagged on the ray trace anti-aliasing, because the ray trace anti-aliasing takes the normal and uses that. Which, come to think about it, if we do custom material normals, they ain't gonna work too good. We'll check if it's perpendicular to the view ray. Maybe we've got to take we got to figure out a new metric, which would be interesting. But yeah, these ones, because it's like one ellipsoid being vertical and the other one like horizontal, the bit where they meet is here, and that is obviously not going to give you a normal, which is like perpendicular to the camera. So the ray trace anti-aliasing fails at that. But Supersample does this really well. And it could be better though, right? You could always have more subsamples. Actually, this is actually even worse than I expected. It's super sampled anti-aliasing at 4 times, meaning it's 16 subpixels. So that's why it's 24 milliseconds, because it's quite a lot. Okay. This is good. All right, I like where we're at. So we've got to do this again one more time for the multi-sampled anti-aliasing, which is the optimization of super-sampled anti-aliasing, where we only do 1 material sample per object, no matter how many subsamples hit the same object. So the shader is a little bit more complicated. That's why I saved it for last, because it's the most complicated one. Just a little bit. Hopefully we don't get too destroyed by this one. So there's hit lists there's hit list arrays, because basically you need to deduplicate all of each subsample, so subpixel, can get you need to deduplicate that hit list such that when you go over at the end, when you go over and do the material shading, sorry, not material shading, when you go over and do the front to back blending of already pre-shaded material colors, you can do them, you don't do them once for every pixel, you've done it once per unique hit list array. And the hit lists are 4 entries, aren't they? So our hit list, I think, fits into a single U32, but we might change that. So yeah, beforehand we also deduplicate all of the ellipsoid hits as well and just only shade those once. So yeah, it's gonna be interesting. So my first question is, right, so this is an array of an array. It's just each byte of this integer is something. Hang on a minute. Just got to figure it out. Front to back, 8 indices. Why is it saying 8? I don't lie. It's supposed to say 4, right? Right, time to decode how this works. So hit entry mask, 4 bits. Oh yeah, I remember now. Basically, I wanted to store a weight. Hang on a minute. Oh yeah, I wanted to support 8 hits per U32. So, but we only need 4 now. So we might be able to change this a little bit. So how do you check if one array is equal to another array quickly? You pack it all into one single integer and just compare the whole in, however many times you need to check it against. So yeah. So each entry I think is 4 bits. Pretty good, right? So yeah, if you divide 32 by 4, it's 8. But I guess we can swap it around the other way now. We can make it, them 8 bits only have 4 entries. Because, so, okay, interesting. So, you've got a deduplicated list of ellipsoids that have been hit. The hit list will index, the indices that it's holding is an index into these arrays here, right? Man, there's so many deduplicated lists of things, but it's just funny. So yeah, we're going to change it to actually be a mask of, because we 8 bits, there's only be 4 entries per hit because it just matches the rest of them. The more hits we have, the more complicated it is going to be to sort them in the shader front to back per pixel. So we limit to 4. We can do that nice hard-coded sort function. And we have four unique hit lists. So hopefully, yeah, and if you, so hopefully all of your sub samples that have their own hit, that generate a bunch of hits per sub pixel, sub sample, same thing. Hopefully each of those sub pixels don't generate different hit lists. If they do, we just reuse the last one in the array and that's it. So you will get some, so the pixels could possibly look incorrect if you have a bunch of small complexity, like sub-pixel complexity, but should be fine. So MSAA ellipsoids hit capacity 8. So 8 unique ellipsoid hits. So maybe we could change that number at some point. But I think I was worried about just the complexity of all the variables going on. But I think this is looking alright compared to the other ones. Yeah, maybe we can change that to like 12 or something, but 8's alright. That can work. So the weights mask, that's just when you saw a bunch of weights. So the weights come later. So when we have this hit list, the hit list will have a the hit lists have, if multiple subpixels have the same hit list, the weight goes up by 1, right? For each time they share the same hit list. So then when you do the shading, you just multiply it by the weight and then do some average, a weighted average, right? So I guess let's go through the shade. Right, yeah, so now we know the shader, or the basic idea behind the shader. Before we go over and check it all, let's just quickly copy all the necessary bits and bobs, bells and whistles all over. This is the sorting code. So what is this doing here? Rasterize, local hit list. We don't have to do that shifting anymore, I don't think. Anyway, we'll just copy these things in. I need this opaque hit and near thing. I think it goes there like that. Hang on a minute. No. I think it goes there like that. And then I need hit depths. Interesting. I'll need that and sort them, isn't it? I need this whole if statement. So when we hit, so that's the sort of, we've got to rewrite it actually. So this is the new, and this will just be the old. There's a lot of deduplication going on. It's a pretty wacky. There's lots of little for loops going on. Right, so I think we got up here looking good. We've got all these bits basically. So the final bit is, so you can't do the accumulation alpha thing. Right, I guess let's just sort out the hit listy stuff and sorting it, and then we'll worry about the material shading bit after, because it's a little bit different. Right. Okay, so deduplicate a list of ellipses that have been hit. For some reason, I go over and do a loop and do that. Oh yeah, that's because it's got that many. Oh yeah, because you can change it. Okay, makes sense. I'll just unroll anyway. Okay, so we go over each subpixel. So we've got it currently hard-coded to 4. So it's 4 times 4, which is like 16. Subpixels, right. So we get the subpixel coordinate, get the subpixel ray through the pixel. Accumulate alpha will come later, we can get rid of that. So there's no earlying out at this point anymore, which is sad, but this is the way. So we generate a local hit list in this MSAA shader. And again, we store all of this, stores 4 hits, just shuffled into a single integer, just so we can do a 1 integer comparison, and boom, jobs are good. So we're using 8-bit entries now, just to make it easier, rather than 4-bit ones. Now we go over all of the roughly sorted front to back ellipsoids and do a reverse ellipsoid. What we used to do is go over all of the ellipsoid hits of find which is our ellipsoid hit index. Sorry. Yeah, see whether we need to insert into it or not. And if we do, we insert into the deduplicated list of ellipsoids. And if not, max the number. What the hell is this doing? Okay. This is a little bit confusing. So it's not really, it could be inserting or updating. So it's taking the min of the t near, but it's also overwriting it as well. So it's like an insert or overwrite. And then this one is saying, well, you've overflown the array, so just use the last one. Like just use the last ellipsoid as a bit of a fallback. So you'll get a bit of a graphical glitch there, but hopefully you don't have eight ellipsoids over a single pixel. Which get hit. 8 different ellipsoids over a single pixel that get hit, hopefully. Yeah, so the more of those that we have, the more expensive this loop can get. So this is a way also to optimize it with a bit of a graphical glitch that could possibly happen. But after 8, you should hopefully be behind enough of them. Yeah, I don't know. Right, so this is then... So can we keep this? The answer is yes. And I don't think I would change much, so I guess let's move this old thing down here. So what is this saying? Local hit list entries count. Shift right and insert into the high bits such that the front ellipsoid ends up in the most significant, sorry, the least significant bits. Okay, so yeah, we insert the back and then we shift right such that we can just peek, just do an AND operation when we take it off when we process it later on. This makes it easier that way. So right. So this code used to assume you just basically insert them on and just forgot about it. We can still do that, but we need to have a way to overwrite the opaque hits. This is the new code that we're going to try and integrate. Here's the early out alpha code, which we can get rid of. That is done later on. Now, so this is the early out code. Let's try and integrate this new code, which is the near, which checks to see if the bounding box near depth hit is greater than the opaque far hit. If we've hit something that's opaque, and it's so if we hit an ellipsoid which is past, which is basically guaranteed to be not overlapping, or at least we hope to be not overlapping off our current opaque hit, so we can early out. Now this code here wants to insert or overwrite. So I guess we're merging these two bits here. Now I've got this word insert index, and it's a little bit confusing, so I guess we can rename it. This is the E insert overwrite right index maybe. Oh my days. Yeah, can't get better than that. Cool. So this one here then, how are we going to merge this? So this code was talking about insert index into the hit list array. So The hit list is zeroed, right? I guess it doesn't matter because we probably and the bits and insert. Is that right? Local hit list is zeroed. So I think the way we're going to do it is we're going to we can't necessarily do the shift right thing anymore, but we're still going to respect the fact that the first one ends up in the least significant bits. Gotcha. So this code can still stay, right? It's the code where it goes, if the alpha is, or if it was transparent in some way, then just insert it at the back of the hit list if there's room. I guess we can rename this one to hit or H insert index, just to sort of make it a little bit more distinct because there's another insert index above this one. Cool. If it's opaque, else if it's opaque, right? If there has not been a previous opaque hit, overwrite the last entry if it is full. This is why I got this min operation here. So we do need to change these from SSAA to MSAA. There we go. So we try and insert it at the end of the array, but if it's full, we insert it at the back. We just overwrite the last one at the back since there hasn't been an opaque hit yet. We support up to 4 hits per subpixel. So you support up to 4 layers of transparency if there's no opaque hit, or 3 layers of transparency if there's 1 opaque hit. So if you happen to get an opaque hit and you've had 4 transparent ones, you just overwrite the last entry with the opaque hit. So you set the opaque hit index and you finally set the hit far. And then if you had an opaque hit, but you already have an opaque hit that's you've already come across an opaque hit, you check to see if this new depth is closer, and if it is, you overwrite the current opaque one, right? And then here, this code is just saying, so this was all about determining the new index, and this code is all about actually doing the insert. So I had, when I initially wrote this, I had 3 different places where I was inserting. It was proper, like, these were bigger if-else things. And this is the best I could simplify it down. So if the, let's get that music back. It's by face. So this hit list, we up the hit list entries count. Now, this is actually called local hit list entries count in this shader. So I want to change that. I'm going to move that down so it's sort of structured a bit nicer. Right, so we've got this sort of like hit list entries count. It's got to actually be renamed out for these ones here. Cool. Now, remember this is just a U32 in here and we're packing them all into a U32, which is super nice. So based on this H insert index and all these things, we need to say, right, local hit list, we're gonna and equal the not of 0xff, which is probably better off using the MSAA hit list mask, entry mask, which is just 1 byte, shifted left by the number of, or by the H insert index multiplied by 8 bits. So that will give us basically a mask which will either be 0xff 000, right, so that's the one in the high bits, or it will be that one, or that one, or that one, right? So that would be 0 will get you that, 1 will get you that, 2 will get you that, 3 will get you that. So there's the 4 entries. So that just ands it out so that this just removes what was ever previously there just in case. The only thing that would ever do this is this one here, but just to, you know, yeah. Maybe I could move it there. You know, maybe we could move it here. I don't know what would be better, but I'll move it there just in case. Just so logically it makes sense, but it might be better performance-wise just to join these up. And I'll look into that later when I actually want to micro-optimize these things. Far in the future. Now the final thing we would like to do is actually insert something into there. So you OR in, you take the E index, which is the thing you want to OR. So this is a, you know, this would be basically 0 to 8. It's very small at the moment, but we can always up it. And we simply just shift over into that slot and then OR it in. Cool. So we don't record a depth hit into hit list depth because the hits are actually, the depths are actually recorded as part of the deduplicated lists of ellipsoid hits. So we just take a min operation for every one of those, right? So that's why it's separate. So they're shared for the overall pixel and not done at the sub-pixel level. Cool, so now that's been adjusted, I'm happy with that. We can delete this code here because this does what this code here now does what this code used to do. And that is the new updated one. So now that we have cool. So this will simply just generate a hit list, a local hit list. So after that, we need to do some sorting front to back per pixel. So this used to handle, so this is where we've got to change this macro here. So you've only got 4 possible values. We just assume that all 4 are always, we just assume that all 4 values are always active and have a valid value. So we've initialized all of our depths to infinity, meaning whatever thing gets indexed we've got to be careful here. Maybe we should initialize the hit list to yes, the way this used to work is that the depths were initialized to infinity, but since the depths are now indirectly accessed based on the oh, what are you bugging? Well, we could make this an array. You know what we could do? Rather than keeping it as bit packed stuff here, we could make it an array first and then bit pack it after the sorting. That way this would be not be doing a bunch of bit maths and stuff, which might be a bit unnecessary to be honest. And then that local hit list can be condensed into an int and then compared quickly, yeah. That might be better. So why don't we make local hit list an array? And then the code will be like, MSAA, here list entries cap. So yeah, maybe then. Just maybe. So that wouldn't need to exist anymore. And this will simply just take I don't know why I just copied that, to be honest. Right, so this will be h insert index equals e index. That might be better, because it's not just packing for no reason. The only concern would be if you over allocate some registers, but I don't think we allocate a lot of registers here. Maybe we do. Solve that problem later. Right, so now they're in that array, we can, we'll pack them down later. So there's a sorted hit list now. This is gonna so to get the depth, you need to do this sorted hit list, which would be 0, 1, 2, 3, or 4, and go into the local hit list, which will get you the the ellipsoid, the deduplicated ellipsoid hit index, and then go into the depth, right? So what happens if, so this used to just look into hit list depth, and they all used to be set to infinity, but now it's done in this sort of manner. Whether it's indirect to be e depths. E depths. Right. So my concern is now there's a bit, I think it's a bit of a bug where if you're so your local hit list has to be initialized to something where if, so you're searching 4 elements, right? Sorry, you're sorting 4 elements always. So even if your hit list hasn't got anything in those elements at the back, they could still be sorted in front if their value is not initialized to something which will point to a depth which is infinity. So that's what we've got to somehow achieve. So if the deduplicated list of ellipsoids is, so say if we initialize this local hit list to point to the one at the back, right? You've got 8 of them. And say if you filled up this array, then it would still be a problem if we made it all point to the one at the back. Because say if the hit list only hits two elements, well 3 and 4 point to the ellipsoid at the back, which is initialized to some depth, which is not infinity. So what we need to do is we need to actually add 1 here such that the sort indices can always point to one which is initialized to infinity. The extra element is always infinity for the sorting code. For the sorting code, when local hit lists entries count is less than 4. For the uninitialized local hit list entries to point to. Something like that, right? So we can avoid the extra checks in the if conditional checks, right? So that means then we can say that each of these, I guess I'll do a for loop here. Get rid of that +1. So we go over all of the local hit lists and initialize it to, so this element always points to infinity depth. Used by the sort code. Initialize pointing to the ellipsoid element that is always infinite depth. Cool. Nice. All right, so let's solve that problem. So now when we do this, they will always be infinity depth if they are uninitialized, which is cool. Amazing. Right, so this used to be some shifting code because I was only using like 4 bits per entry before, and this would then mean that if you only filled up 3 elements and you shifted in from the most significant bits, they would not be shifted down to the least significant bits, so this just shifted it to the least significant bits. But we don't need this anymore, but instead we need to write some code which will create a local hit list as a single U32. So we're going to go over all that sort list, basically. So we create that hit list, local hit list. We'll call that a word this time. Initialize it to 0. And all we're going to do is... Wait, do we initialize it to 0? How does that work? How does it earlier when it goes on the hit list? If wait, how does this even work? Because you can point to the 0 index. I think there's a bug here. How does this even work? What magic did we pull off? I gotta change that comment because it's no longer. There's a weights. What's that weights doing? The weights for all the hit list. Shouldn't there be a count for each hit list? There was never a point in time when 0 in a hit list was something that was invalid. Because you're putting the the ellipsoid index into the hit list, meaning that you can always point to the 0 element. So that's a bit of crap, to be honest. Maybe we need that special slot here. That could be our invalid values, this constant here maybe. But yeah, we'll change it to that. Right, hit list weights count. No, weights. Yeah, they're the weights each. Right. Let's change that. Okay, so that's just for later on. So, right, well, I'm glad we know. Right, so basically we want to. We don't have to change anything. So we go over all of the. We'll call this the. So we'll go over all of the hit list entries in the sorted hit list. And all we're going to do I guess we insert backwards like we were doing before. Is that true? Where's that code? Let's take that. Right, so you take the hit list word, you shift it right by the number of bits per entry, which is 8 now. Then we OR in the local hit list indexed with the sorted hit list index. Oh, I used to add 1 to it. This is where 0 wasn't not an invalid value. I used to add 1 and then probably took away 1. Right, I see now. Right, I wonder why that was, because it seemed like it would be buggier if that was a bug. But anyway, we've changed it to be a different invalid value now. So no longer do we add 1. Oh, I still need to do a shift. Don't mind me. Yeah, so we shifted in, shift right, and sends the higher bits. But why do it that way round when you're going over all of them anyway? Why not just... Because this initializes 0, just OR it in. SH index multiplied by 8. But that'd be multiplied by the MSAA hit list bits. Hit list entry bits count, so it's 8. No plus 1. So yeah, least significant bit first. Do we need to up this? No, we don't. Great, so we just basically can, compress that down into a single int, such that now we do the deduplication process. So pack to E32, and then this sort of deduplication process becomes simple within four checks at a time. So I guess we could say pack the sorted hit list. Now we're doing 4 checks at a time over all the hit lists that we found in the past. Right, if it's a new entry, then we insert if it's not full. If not, we just use the one at the end if we've run out. We only support up to 4 distinct hit lists for performance reasons, but also, yeah, mainly just for performance reasons, but also we don't think you're going to hit it. And then we up the weight for that hit list. So we've got, again, a weight of each byte within the weight, each byte in this 4-byte integer is an entry. So each hit list gets a weight. So if you've deduplicated it to the same one, then the weight goes up. Deduplicate the hit list, and then up the weight, and voila. So that's looking good. Looking like it could work. Now there's the next step to this shader is after you've basically got all these different hit lists. Now this is where you do because you've deduplicated the ellipsoids and the different hit lists, you can do a minimal amount of work, and we batch the work into their own little for loops, such that if pixels within the same wave of 32 threads that run in lockstep they're more likely to run a similar number of times. Sorry, what's the way of saying it? It's more of like a general. We've generalized this for loop into being what's the number of unique ellipsoids that you've hit for this pixel, right? It's running a loop for as many unique ellipsoids that have been hit, instead of saying instead of going over all of the hit lists and then going over all of the ellipsoids within the hit list and shading those ellipsoids and having like a multi-dimensional loop, which would then you'd have 2 for loops which have different sizes, so there'd be lots of inactive lanes. So it's just batching all the work together in these deduplicated lists, which would be a bigger performance win. It's still going to be like much slower than just rendering 1 pixel because we're doing sub pixels, but it's better than doing super sampled anti-aliasing because we did test that out. And we'll still get to test it out in a big scene though. But yeah, it's been, and with multiple different materials. But yeah, we've seen benefits already. So sample each hit once. This does all material sampling, even if multiple sub-samples hit the same ellipsoid. This is where the wins are at. So this code does not have to change. We cannot early out here, unfortunately, because it's not in a front-to-back way. It's just a deduplicated set of material samples. So yeah, there's no way to early out, unfortunately. Even if the hit list never uses that material sample because it reaches an opaque pixel. So that is a shame, but yeah, it's just the way it is sometimes. So that doesn't have to change. This one does have to change though, just a little bit. Loop over all the deduplicated hit lists and blend the hits front to back, and accumulate the color and weights based on how many subsamples share the same hit lists. So we got at most four unique hit lists, and again they've got a weight, so it saves us doing it multiple times. When the same subpixels hit the same stuff, we can just multiply the result and just do a weighted average, right? So for every hit list, go over all of the entries. Now this visits every single entry, then earlies out when hitting a 0, 1, but that's because we used to add 1. But now we instead put in the MSAA. I think it was the ellipsoid hit capacity. Now I could be careful, did I? Yeah, ellipsoid hit capacity. Good. So it's equal to this one. Then we break because we found the end of the list. So we've essentially got like a null terminator, if there is one, kinda. But it's not the null value anymore. Then we extract out the O, the object index, be the ellipsoid index. So we just do the AND mask, no take away 1 anymore. And then we extract out the color from the material shading and the hit. Wait, why do we get the E index? What's going on here? Oh yeah, then we get we go into the tile ellipsoids, fetch out the proper ellipsoid index for the whole big ellipsoid buffer. So this is per tile, this is per frame. Then we do a front to back blend, and then we just shift right the whole list and go to the next entry. And we go again, do the front to back blending. Now we should be able to do a little bit of magic here where we say if the color dot A is greater than or equal to 1, we have reached an opaque hit, meaning yeah, I think we want to say closest hit is infinity because this is the other thing that we did. And then we changed it to mean oh, did I not change that in the super sampled NCA listing? What did I do? I thought I did something. Oh yeah, I did change it. I just don't need that comment there anymore. And we don't need this if statement in here anymore because that'll just be a wasteful check anyway, because some branches will probably run it. Cool. Right, so I fixed that one up, nick this line. So in the MSAA shader, we go over all the hit lists. We can do a min operation here. And we want to take the current depth of this ellipsoid. So E depths object index. Cool. And we min that with the closest hit. So that will mean that even if we've got transparent objects and they end up going towards something which is opaque, like accumulate something which is opaque, then it will produce a nice closest hit opaque depth value. Oh, nearly there. So yeah, if we don't reach an opaque hit, or yeah, don't reach something which is an opaque color, then we just sample the cube map and blend that in, obviously. Now this is where we do the weighted summing, right? So we sort of scale the color by the weight based on how many subpixels share the same hit list. And then we accumulate the total weight and the final color. Then at the end, we just scale it down. We divide by the inverse total weight. Bright pixels, e.g. Luma 10, on the edge of an ellipsoid cause the average to still show bright pixels. This is probably due to the fact that we don't render. Why did I put this here? Yeah, I think we saw a problem with the way it was doing the averaging, I think. Oh yeah, of course. We're doing a weighted average with color values in an HDR that's going to be like super bright. So we might want to do a weighted average in log or in exponent space. So it squishes them down closer together type of thing. Right, and then we just poke the values out into the final textures and voila. So hopefully we'll just fire up the MSAA shader and take a look how that looks. Hey, Elwood J. Finley, welcome back, sir. How you doing? How's the weekend? Right, hopefully this is... Shoot. I thought I undeffed it. Oh, for crying out loud. Undeclared identifier. Hit depths. Good point. I completely looked over that code. E hits. And you got to index that with the local hit list to get the ellipsoid index. Then, sorry, then you get the depth from that array. Right, 4589. That is because I didn't put the word on the end. Again, I didn't put the word on the end. Hopefully, it works like a charm. Damn it. Well, sometimes you win some, sometimes you lose some. The background is incredibly glitchy. The ellipsoids are also a bit glitchy as well. This is interesting. We've got to screenshot this. So yeah. Might be a bit broken. Just a little bit. So what could that be? Good question. Ah. No? Okay, so I guess we'll go down from the top and we'll figure out we'll look at everything, see what we're doing wrong. So at most 8 unique ellipsoids, 4 unique hit lists. Each hit list has 4 entries, 8 bits per entry, has a mask of a byte, and then a weight mask as a byte, 8 bits per one of them. Radio. Cool. We also have such a thing as our deduplicated list of ellipsoids. That screenshot is prime candidate for bug collective for a bug collective on the graphics program Discord. I'm not actually in that one. Maybe I should take a look at it. I'm in the Vulkan one. Have you got a link to the Discord? I better barely go on it. When things are like super busy, I'm like, Yeah, last time I looked at him was November. I don't even know how you join more Discords. How people find them. I just only have joined invite links. So we wanted 1 extra for the depth. That's okay. Seems alright. Nice. Rasterize the ellipsoid's final. This was that we hit. Generate the hit list, right. So what else did we change? So this local hit list thing, and we instantiate to this value here, which is like 8 or something. Go over all the ellipsoids, do your array versus ellipsoid. Early out. If we have got an opaque hit and the bounding box of this hit that we've done is far enough to not be overlapping anymore. Go over all of the ellipsoids and find an insert index or an overwrite, insert or overwrite index. What is this? If the count is less than. Aren't you really just saying... I think that's a little bit odd. I don't think this is the bug though, because I didn't change this code, but you should really say the insert index. It's a bit different. Maybe. A little bit safer. I think both would have worked. So up the count if it's at the end of the array. And insert or overwrite these guys. So that doesn't really change. Cool. This is the new code. So we take the hit insert index. If the ellipsoid alpha is transparent, we insert it into the array. Oh, opaque hit index. Yeah, so we haven't hit an opaque one yet. Yeah, it's equal to the... It either overwrites the last element of the array or reuses the... Or insert... Yeah, it inserts into at the end of the array or overwrites the last element in the array. Because we have to have an opaque hit over transparent hits. But if there was an opaque hit, we see if we're the closest one and overwrite that one. Now, the overwriting actually gets done here. So where it ups the count based on if it's the last one. If not, it just puts it in there like so. That's okay, I think. I can't see any bugs with that. So here's the sorting code. So the sorting code just basically swaps the sort hit list around. And we've got 0, 1, 2, 3, 4 type of thing. These are initialized to like the final element in the array, which is equal to infinity. So if you come across, if you're trying to swap elements which are not initialized, they'll be set to infinity on the depth. Yeah. It all makes sense. So let's just double check. So you do your sort hit list, you get your local hit list index in the depth, and that's with B, and then you do your swapping. So that all seems good. Now, this one goes over all of the entries in the list, and it's going to OR so instantiate to 0, and then OR that into the least significant bit, and then the next bit up. See that this is 8 bits, so it's doing 1 byte at a time basically, and this is not going to overflow. I'm using e-index, aren't I? Crap. E-index is the index into the... No, what is e-index? Yeah, what is e-index here? What's going on? Yeah, bugger. That's the wrong one. Right, we found the problem. I think we want to be using the insert overwrite index. That's why I made this deduplicated list. Or one of the reasons is so we have a smaller index. But the other reason is that it's deduplicated and we can just do the material samples as well. Right, I think that's the bug. So it's overflowing and causing index out of bounds on all those pixels. Well, the ellipsoids look better. So it seems like it was a combination of bugs. Those ellipsoids are looking good when I disable the occlusion buffer. They're looking alright. Still getting some weird little jagged lines, so I'll look at that. Cool. The next thing to look at then would be, that seems to be to do with the sky. I think. The environment map. Why? So this is never running. Is that what we could say for certain? So that's 1 byte. This is what it'd be if it's uninitialized. So if you've got nothing in there, it should just have nothing but all of those in there, right? But it might be... So what we can do is we can find out what is this list equal to in hexadecimal. And we're looking for the number, was it 8? In it, so 8 is, I think it's 0x8. So yeah, if we do a GPU, we'll do an if is mouse at, pass in the pixel coordinate, and then we'll just do a lovely GPU print. I want to print out the hit, the list. That will be processing. So there should only be one list per all the pixels that we hover over, but that are just pointing towards the sky. Wait a minute. Yeah, I think so. Oh crap. I didn't do it in a hex, did I? Because Then we can actually tell what each element is, because there's 4 elements in a single int. Right, as we expected, there is a 808080, but I think there's a 00 at the start. Oh, there is this one. That makes sense. Perfect. So I just see down here, 808080. So surely the alpha is less, like, doesn't it? Is the weight 0, isn't it? How did this used to work? So the weight would be... No, there still must be some kind of weight, right? Okay, so what is the... I guess we put this in here. So now it only prints out this list thing if there is some kind of sky that's processed. So it's not printing out here. Go over here, still not printing it out. Bit scary. Initialized to 0. So I don't think this is alright. I'm being a melon. Instead, we want to say, right, if the O index, when we extract out from the list, is equal to that invalid value, then we're at the end of the list. And voila. There we go. So this is the multi-sample anti-aliasing shader. It's, again, slower than the ray trace anti-aliasing. This is 16, so this is 4 times, so it's 16 subpixels per actual pixel. If we press the F4 key, we can see the performance. Now, if you remember the super sample anti-aliasing, that was about 24 milliseconds for a scene, something like this, I think. I don't know. I honestly can't tell you what it, because it varies so much depending on how many. But yeah, again, this is on a mid-tier card at like, so this mid-tier card should only really handle 1080p. Really. So yeah, these numbers are okay. This is like 16 times the resolution at, sorry, 4 times the resolution, but at like, you know, a resolution in between 1080p and 4K. So I'm not really too fussed about this. But yeah, we can optimize this shader even more later on, I think, if we're worried about it. So let's take a look at some of these images and just see, like, oh, not this one. If we take a picture of this, I'm seeing some jagged edges basically, and that is a bit strange. So I want to know whether or not we have done it a disservice. Yeah, there was that bright pixel thing where I said because it does the weighted average in such a way that you don't... So I think that's because of the lights. It might be. Right, we see the edges here. These are okay. Right, they're anti-aliased. But I think what I... You know, if we... So it's because we're not doing it in log space, I think. Like exponent and log, like... So if I try and get like a bright edge... Yeah, I don't have a bright... Ah, there you go, we get bright edge there. Would I? I don't know, there's already bright edges. Maybe I have to zoom out a bit. So I'll take us that screenshot instead. Yeah, these I guess are not anti-aliasing. It's hard because they're not on the edge. That one kind of is though. But yeah, I don't know if it's to do with the bright lights or anything like that. But sometimes not. The super sample one did work better, obviously. There might be a problem with the code. It's kind of looking jagged though, isn't it? I could really see the jaggedness there. I don't know. But anyway, can look at that later some other time. But at least we got those ones back in order again. So I'm happy about that. They're now corrected. So as you see, they're sorted front to back per pixel now, which is super handy. Right, so one more thing on the agenda for today, and that is sorting out the that's all right. Yeah, perfect. I'll be able to join. Thank you, the Teva. Phew, I didn't get announced into the server, so my anxiety is like... Cool, I'll take a look at it sometime. Get out of here. Maybe I'll put you above the Vulkan one, I don't know. Whoa, doesn't that look nice? Lit. Right. So the next thing on the agenda is sorting out the occlusion culling. So the occlusion culling has a bug. So we'll switch back to the ray trace anti-aliasing shader because it's the quickest one. Doesn't fry my computer while we're trying to stream. And we get some reasonable bit of anti-aliasing. See this bug? The wrong amount of stuff is being occluded. So I think it's to do with an issue where I'm sampling the occlusion texture with the wrong coordinate. Seems like it's possible. And then I want to do a debug interface, sorry, a debug ray tracer with the like a heat map, because Temvar showed his pretty cool image, to be honest. Look pretty nice. Where it has like an overdraw debug view with a colored depth to color heat map thing. So I think it's debug drawing overdraw. That's why it's lighting up on the edges. Can you see on the edges it really lights up hard? Are these voxels, Tempfar? So yeah, we'll do something like this. Ours is not going to look exactly like it because we don't have... Wait, will it? On edges it might show up. I don't know. We'll find out. So I think we'll do something like this to help us debug this occlusion culling, just to sort of see stuff getting rejected when it goes behind stuff, right? And we can always put an object in a particular place and just watch it go behind the and another set of objects and see it disappear, and use that as a way to debug. I was thinking about a more sort of hands-on one, but I think when we have like an editor in, we won't have... Why are we building a specific system just to move around an access line bounding box when we're going to have that in the editor anyway? So we'll be able to turn on this heat map mode and then just sort of drag an object around and watch it get occlusion culled. So we can always use that as some debugging way to debug, right? Cool. Right, I'm just going to get a quick drink and then we'll resume on this occlusion culling fixing stuff. They are voxels, awesome. Yeah, they did look like voxels. That's cool. Have you got any more other sort of... It was this a little voxel renderer you did? That's cool. Have you, what other stuff you got? Did you do anything more with this project other than just this sort of test scene? Right. BRB. Alright, hello everyone. How's it going? Hope you're all doing good. So, excuse me. Yeah, I went a bit further with it. It was an SDF evaluator, splat cluster renderer. Right, yeah, so you splat the clusters to the screen and you pixel shader, right? And then you ray march into the cluster. I think Dreams calls it the brick renderer. I think they do the same thing. Where the splats are cubical axis. It's a bit different. These are axis aligned, right? Oh, so you're doing it into an actual volume. No. Not a axis aligned. Maybe you are. So is this a whole big volume texture for the whole scene? Oh, it's a sparse voxel one. Okay. I don't know why they need to be axis aligned. Because surely it's a transform into the world, maybe. Oh no, okay, yeah, sparse. So it's a, yes, it's a, right, sparse volume texture, gotcha, yeah. Ah, raster or computer dependent box size. Nice. Hey Raf, how are you doing? Welcome. What's going on? Oh, why didn't I take this off before I came back? One of them. Oh. It's getting hot. Yeah. Just chuck that over there somewhere. Cool. So... Right, so the bug... Let's just quickly get a bit of visuals back to what the bug is, just in case people have popped in since the break. This is the bug. Look at it. Horrible. So there's occlusion culling invalidly. And I think it's because the sample position is wrong. I had a... my laptop died, so I'll be back on chat in a minute. When my laptop boots back up. So effectively I went from manually sampling a 2x2 region in the occlusion texture, which looks something like, or which looks like this. And then, sampling a 2x2 region at a certain MIP level, and then minning or maxing the depth or something like that. But I was doing it with pixel coordinates before, so I was using the bottom left of the rectangle when it was downscaled. But now I'm using a sampler. I need the center position of the is occluded. Yeah, I need to use the center position of the rectangle rather than the bottom left. So this coordinate needs to actually be half width and all that stuff. How's the engine coming along? It's coming along quite okay. We went back to... So I was starting to work on the material editor. And, I got the editor UI in for that. We did some Gizmo stuff. We got an entity system in. We got an encoder system in for serialization. So I've got a custom C-like encoding. There's a good example. I've just done... It's just basically you declare some type information. Types, you can say you want to be text or binary serialization, or maybe it just targets the GPU and doesn't serialize anything. And it's a way of doing versioning and declaring types and getting code generated stuff back for serialization, but then also doing some packing. It supports some like crazy packing syntax, which is useful for like GPU stuff, because in GPUs you really want to like pack stuff down. So it's like, yeah, you can do some, here's the ellipsoid. When I do it packs, I can pack floats down into these sorts of, with this sort of syntax. So yeah, we built this system for the editor basically to serialize and do versioning, but also for the GPU to use it and auto generate some nice packing code without doing crazy macros manually. And what else did we do? Yeah, here's the material editor. It's going to change again. But yeah, basically you get your... I got to sort out this model. But, we did this color picker as well. It's an OK LCH color picker. And for some reason with the DPI scaling, it's not scaled up properly. That's the problem with the popover. We can fix that. So we made this too. Emissive, we've still got to do emissive. So right now emissive just sort of makes the overall color go up rather than it sort of blowing out into your face, which we've got to add support for that. Got some sort of light history thing here that's not really got an undo on it. And yeah, we've got PBR, make it rough. And yeah. So this is how the editor's been going for... Yeah, we started work on the editor, and then I wanted to... I was like, you know what? I need to add support to the... support for multiple materials, because we have a material editor now. Because right now, every object has the same material. So I was like, let me change the renderer. But the renderer was slow, buggy, and I was like, I really want to rewrite the renderer again. Something that was not slow and buggy, and get it all polished off. So this is what we're currently doing. We've got 3 different ray tracers. We've got a ray traced anti-aliasing shader, which is kind of a made up thing by me. Super sampled anti-aliasing ray tracer and a multi-sampled anti-aliased ray tracer. Got a bit of a profiler here as well with F4. So it's rendered by doing a screen. We bin all the ellipsoids into screen tiles, so each pixel, when it wants to ray trace against the ellipsoids, it just checks a smaller list of ellipsoids to look over. It's a little bit more complicated than that, but that's the basic idea. What else? Yeah, so right now we're on the tail end of the renderer rewrite. I'm hoping to be finished by this month. And then we can get back onto doing the material editor and do some proper materials, like rather than this basic one where you change some properties. We'll support textures and things, and yeah, have more properties to change. So yeah, it's come along well. We're in a sort of editor and renderer type of thing. We'll add support for doing a model editor because we've got an ellipsoid renderer, and we'll do a basic level editor as well, so we can put together a scene. And then after that, we'll go back. After we have those things, we'll go back to doing the renderer again, and probably add maybe some kind of skeletal kind of animation because we'll just have static objects at that point. Or we'll probably do some lighting first. It'll probably be lighting first, like proper lighting is right now. I've only got 2 lights. Well, one light that just moves and it's cyan or teal, and then one white light. So we'll, whenever we can sort of build some kind of environment, we probably want to have other kind of lighting. So yeah, that's how it's coming along. So the is occluded needs to, since we're doing a sample with a max reduction sampler, we need to make sure that we offset this by 1/2. So I want to get a half pixel, whatever that is. Why did I say chord and then not even use it? That's a good point. Half dims. Width divided by 2, height divided by 2, and then I would just basically add the 1/2 one here, and that will do the... We'll calculate the proper UV. Yeah, and also the scene dims is as if it's full resolution, isn't it? Yeah, I think that's another kind of potential bug. Right, that seems much better. Still got some issues, But it seems to be that we're only missing a few things here, because if we turn off the occlusion buffer, they show up again. So it's definitely much better. What happens if I go like that? Okay, maybe not. Yeah, when you get too close, that's a different bug. Okay. So, what's the problem with this one, then? Are we selecting the wrong MIP? I think I did this take 1 here for a reason, because of, like, the resolution was different. But let me just double check, see if that fixes the problem. Whereas, oh, yeah, we still have the bug. Right, so best. Right, so let's go. So our occlusion texture, it's the highest level, the highest its base resolution is half the resolution of the scene dimensions, right? Because scene dims, the reason why it's called scene dims is because it can be the size of the screen, but if you're in the editor, you want to render a smaller little window within inside the actual screen. So if it's occluded, we're checking in the occlusion buffer at the specific MIP level where the box fits into a 2x2. Now, if you take the largest dimension of the screen bounds that we're testing, we check the largest dimension of the box and scale that down. See, you would get more pixel, like the error would be getting more pixels, which can give you a false value rather than less pixels, which, sorry, what's the way of saying it? You'll be using the larger dimension and just making a 2x2 from that. Or finding that the 2x2 that fits that largest dimension. Finding the MIP where that 2x2 fits this sort of largest dimension. And the reason why I use the largest rather than the smallest is because when it's rounded up, you get more pixels, which can lead you to fail, not passing the occlusion test more, rather than passing it more, which will lead to incorrect results. So we've just got to make sure this maths makes sense. So let's really look at this sort of calculate MIP map thing. I think there's two things about it, isn't there? This scene dims can also, right, I think I know the problem. Do I? The problem is that there is another problem. The other problem is that the scene, when we render the occlusion using another ray tracer, that is simply just rendering at half resolution into a different texture. Now, if we're using the scene dimensions, then yes, we halved it here. So this occlusion ray tracer checks, or when it does this tile bin ellipsoids, it's using the occlusion buffer from the previous frame. So I think some of that, this is occluded thing, we can't just simply be using, we're able to be passing in the render dims. So it's either half resolution or full resolution. So that will help with figuring out. So sorry, how will that help? So it did the clamping correctly. It will also calculate the correct UV. So it could have been calculating the wrong UV for when we are testing for the when we generate the occlusion buffer from the previous occlusion buffers. Ah, crap. Another problem. We're rendering into the occlusion buffer while using the occlusion buffer. Seems like a bit of a problem to me. So, how can we disable this is occluded thing? So I think we can use there is a sort of a transparent check, isn't there? Is there a, I could say only do this providing that allow transparency. So allow transparency is true for when we do the proper render. When we just render the occlusion and did sort of like a depth pre-pass, when we tile bin the ellipsoids, we don't want any transparency. So we're only going to check the occlusion if we're only going to check the occlusion if it's the proper renderer. What is render dims set to? Well, it's a float, of course it is. Right, whereas this is of course it's used here as well, right? BC allow. So let's see if this fixes our problems. Oh. So the outer one did it on the ellipsoid, sorry, the model instance itself, the inner one does it per ellipsoid. So I'm still seeing some sort of graphical glitches at the edge there. If I disable the occlusion, this all appears here, so there are some issues. If I whack open the occlusion buffer, what do I see? So I still see they're all being rendered in there, right? I think. So yeah, like you see here, you see kind of a flat surface. Here we're still seeing like a bubbly surface in depth. Right. So the problem is definitely to do with the way it's sampling still. Possibly. So let's remove this here. Always put it back in. Let's try and figure out what the next bug could be. Yeah, so we get the bottom left. So we take that largest dimension, right, we take the most significant bit. So if it's got a width of 4, the most significant bit that'll be set is 2. So it's a 4x4 box. So what MIP will it be? What MIP will this 4x4 be? A 2x2. So in that case, we'll do a most significant bits is bit 2. So 1, MIP 2, then take 1, give you 1. So that means you will take your 4x4, shift right by 1, and you get 2, so it'll be a 2x2. Great. Just try another one just in case. Let's say 18. Right, I see the problem, I think. Okay, so let's try 5 instead. Right, so 4 used to just be 2. 5 is going to be 2 as well, right? So it's going to do the same calculation, right? A most significant bit, it will generate 2, which then give you a MIP, then take away 1. So it says at MIP 1 is where you need sample. So we shift this right by 1. That still gives you a 2x2. Okay, so that's okay. Right. So even up to about 7, that's still going to do... Wait, is it? Sorry, what I was saying, 4. Wait, is 5 okay? So it's a 5x5. Are you missing some of the edges then? Yeah, I think it's got to be rounded up. I think that's part... Yeah, so by taking away 1, you end up removing some of the... Yeah, you make the sample area, or the physical sort of area across the screen, will be smaller. The higher the MIP level, the more of the screen you're sampling in a sense. So yeah, I think that around... So the question is though, if I take that 4, okay, sorry, if I take that 5, 5x5, right, so I think you want to do largest dim, take 1, such that 4 so that'd be a 3 then. Yeah, but 4's a... Yeah, that'll get you MIP 1, wouldn't it? That way it'll get you a MIP 1. 2 will get you a MIP. So it's 2x2 already. Then that take away 1, that'll get you... Cool. You need to make sure you max 1 before you take it away though. Yeah, that's a bit better. So then if you do get a 5x5 box, you take away 1, that gets you a 4. Then it says at MIP 2 you look at. Sorry. Yeah, look at MIP 2. So if you take that 5x5 and shift it right by 2, is that too much? So you got a 5x5. Mm. So your half hit. Yeah, it'll be rounded up in a sense. The size will be rounded up, but not the coordinate. Right, let's look at that VK guide where they've got a occlusion culling thing. They've got a very similar thing to what we're doing. So let's see if we've got any logic there that's sort of like different from ours and reason about it. So the bit I'm thinking about is visible check. No, it's this bit here. Right, so they take the max and then do the log 2 and then they floor it. But that's, you get log 2 just by doing the most significant bit here. And they've probably got a clamp. They've probably got a clamp MIP shader anyway. Right. Sorry, MIP sampler. Does it clamp? What do we do with these? I've already got that configurable, the sampler ones. Here they are. MIP bias. Lot clamp, none. Yes, so I haven't got a clamp. Maybe they've got a special clamp thing on their one, so we've got to do it manually. See, what they do is just do a log 2 of the max width height. So what's pyramid? See, my width is just that. What's that sort of project sphere function they're using? They don't really say about that, do they? Sorry, I don't need it anyway. But yeah, so they've got this sort of like ABB that covers the sphere in screen space. And then accessing the depth pyramid at that point. So they scale it already by this sort of pyramid width. Yeah, so it seems like it's doing it in, this is actually a normalized ABB because they're multiplying it by the width. No, they're not. Yeah, they are. Because that's shift. Yeah, that's, so this is the overall width of the tech. Yeah, so this is ABB is normalized already. Okay. So that's the width of the height of the box level. Right. Yeah, so that needs to be normalized anyway. So we kind of do all that, innit? So I was kind of messing around with this a bit. So we're already at half resolution as well. This is the other thing. We're already at some kind of half resolution. So perhaps what we need to do is just use the largest dim. So we're already at some kind of max resolution. Sorry, we're already, the max resolution is already, of the occlusion texture is already half of the scene we're actually rendering anyway, that's already technically going down by 1. So whatever MIP we select, so I guess the way you think about it is like, well, you're just missing the highest resolution. Yeah. So you select 1, it's got to be the equivalent of 0. So you do end up having, yeah, 1's got to remap to 0, 2's got to remap to 1. So what you have to do is you have to max by 1. So MIP max 1, MIP with 1, and then take away 1. Now you do this, our occlusion texture is half, and MIP 0 is half resolution. So adjust the MIP for that. So if something is like 1 pixel big, I guess it's just going to end up sampling the bigger one, which is okay. So we take the bottom left, add the half dims. Now the question is, right, for the occlusion depth kind of pre-pass thing that it does, that one is already binning at the half resolution anyway, so the render dims is going to be so you only really need to do that adjustment if the render dims is not equal to the scene dims. Damn this thing. So you could probably like so you actually need a little bit of an if statement in here where you say if the render dims, I guess, .x is not equal to the graphics global scene dims .x. Just do that as a nice quick check, I guess. Then do it. Right, if they're wait, sorry. Hang on a minute. Yeah. Wait. Yeah, only if we're rendering the scene dims. If not, it's we're rendering out the occlusion texture half resolution anyway. It might be better just to calculate it properly and just do a division, then round it or something. So you could do like well, so this would be bound to be smaller. Do a divide. Probably seal it. Right, maybe. Or round it. So if we're rendering at, so there's some kind of like dynamic resolution over, you should be able to be rendering at half or quarter resolution type of thing anyway. But say if it's 2.5, which one how do you change the MIP? I guess you round it up anyway. Let's just do that. And then that will be the sort of bias. I did divide equals for some reason. And then you put in the MIP bias here. So if it's a quarter, it will go down by 2. Or will it? I need to take the most significant bit on that, I think. It should really be log 2. Wait. Hang on a minute. Then take the most significant bit. So it's kind of log 2 in integer terminology. So if it's core resolution, it would divide by 4, which then get turned into 2. Right. Yeah, bit index 2. Yeah, good. Just the bias. Nice. Alright, so I think that's better. Right, how else do we compare to this one? Depth of sphere. Right. So I don't think there's anything else that's different. This is an interesting ring set. Sadly, doing culling and sorting at the same time is a really hard problem. So in the engine, we do no sorting at all for transparent objects. The culling uses atomics, whose order depends on how threads are executed in GPU hardware. This really has no stability for sorting the final layout. Yeah. Even then, there are ways of working around it if we are doing draw and direct using instancing with one draw per object and set its instance to 0 if called. Right. We can keep the order. Interesting. But if they do that, you have 0 size draws, which still cost performance in the engine, right? It's a novel solution. Another possibility is to sort in the GPU itself. Sort is non-trivial operation. Right. It's interesting to mention about transparency. Don't know how that fits into occlusion culling, because obviously you can't. Yeah, I don't know how, because you'd only put the open. Because you only put the opaques in the occlusion buffer, right? Better than you. Okay, let's see with this MIP bias if it fixes that issue. Because ours is at half resolution. Maybe the MIP bias was what we needed, but I don't know. Right, we're still seeing some kind of like glitches kind of, but it looks like it's, so these were disappearing at the back here basically, if you are just joining recently. And it seems like they're not disappearing. Yeah, they're kind of doing it. Can you see that? That one's gone. If I toggle it, right, there's a few which are. No, but it seems better. Always a good sign. For performance, eh? So if we bring up the profiler, do something like that. So about 3 milliseconds if I toggle it. Right, it doesn't change it at all. This is great. The thing's being called. So that's the UI one. Ignore that. 26 objects being rendered in the culling, 147 being rendered in the final, and then there's 285. Yeah, so it seems like it does help the sorting go down by about 0.03 milliseconds from culling, not that many. So maybe, yeah, we really got to tell this with a big old full scene, whether the occlusion culling is actually going to help for the cost that it is. Maybe there's ways that we can minimize the cost of it such that it is a better trade-off. Like, we're currently sorting the whole scene, and maybe the answer would be find your best objects and only sort those somehow, and don't pay so much of this cost. But yeah, that's a thing to make in the future. Let's just get it working flawlessly, right? So these are already showing up a bit of a problem there. I saw that. That was very weird. Right, so it seems to be like, I see there's a better way to trigger it, but looking at it sort of, oh, okay. Weird glitches there. Oh, that's one in it. Alright. So I guess let's keep looking around for what else could be a problem. So I could try and build that. We could try and build some sort of debug views. If we get two ellipsoids in, we could maybe draw their boxes or something, and then see what's actually going on very easily. And that shouldn't take too much work to quickly program in. So if we go to the game, the not so game, we can literally just put down two entities. And then put them in such a place where one will cover the other one, and then see where things actually get cold. So there we go, right? The simple test. How much of that needs to get covered? So we've got some lovely debug drawing stuff that we can trigger from shader code, so it's just quite easy to do that. So we got to be careful though, because this is actually called, right. So we are going to say if we allow transparency, meaning that this is the renderer which allows transparency, because the occlusion depth render doesn't render any transparent objects. So we are going to then use the draw 2D axis line bounding box min max bounds dot min point and then bounds dot max point. The depth we can just put in as 1 because we haven't really got anything else rendered. Actually, Let's ABS depth reinterpret cast. Well, so because it's a float, you can bitcast it. If you absolute the float and then just bitcast it to an int, it will be, the ordering will stay the same. Wait, is it just an, okay, maybe this trick didn't matter. I think it's a float anyway. It must be a float, right? Yeah, it's a float anyway. Anyways, it's a nice trick. It's useful for GPUs when you don't have float support on like atomics or something. You can make sure it's a positive value and bitcast it to an int and do an atomic min, and it'll be fine. Border thickness, infinity. So, ooh, we would like a border. So let's say 4 pixels. And we'll do a nice color of GPU, nice color E32. We'll pass in a random int. So this will be the ellipsoid index. Wait, no. This is a model. This is a model. So we're only showing the bounds for a model. So let's see that. So we'll get a different color for each model. Well, that was the hope. Anywho. Right, so I was hoping that would have disappeared by now, but it didn't. So we're quite a high field of view, so these green bounds are actually quite bad. And I thought this one would not be oh no. If we do it after the is occluded, we will see it not show up when it actually gets occluded. So that's a good thing to have. Alright, so that's not good enough. So why don't we move the entity back a little bit? So it's at 6, let's move it back to 10. So it should be able to get progressively smaller, and hopefully is small enough to the point where we sample on the occlusion texture and it actually disappears. That's the hope, but a big no-no. I thought if I look at the occlusion texture, look at that, it's there. And if I bring it down to a particular MIP, like it should, it's got depth there, right? So what's going on? So we can continue to figure out why it's not culling. Yeah, I don't know why this is doing a local index thing of, needs to be the same sort of color, doesn't it? Just times it by like 10 or something and see what happens. Why they're both 0 looking. Yeah, they're the same. Oh. Right, of course they are. Local index would be, right. So each thread group each model instance gets a thread group of 32 threads to process 32 threads of. So you want is the group index. I'll give you more of a distinct color. Not that it really matters that much. But there we go. Right, so what's the next thing we can add to help debug this? So the next thing would be, let's take some of the code from the is occluded thing and, I don't know, do some kind of what do we need to know, right? Should we simulate the MIP that you're selecting and therefore like round it to the nearest sort of box that it's going to be looking at? Because we don't really have this, so you can sort of like take it down and then round it back up again. Yeah, I'm not sure. Bounds dot depth is greater. Yeah, it makes sense to that. I would expect it to not show up anymore. Alright, I've got different colors, and there it disappears. Finally, right? So it would be useful to know, like, given this texture, at what MIP level, I guess, did it look at? And then maybe we could get the box and sort of try and work out what's happening. So if we could print out the MIP level in which this thing got tested at. So the way you work it out, you got to know a lot of stuff, right? So why don't you just take all of this, just dump it in here like that. So where we say render dims, we'll just put a BC before it. And then, hang on a minute. I'm doing oh yeah, sorry. Okay, so in here, there's a, I guess we'll want to invert that so we don't do some kind of return. And now here we'd like to just say, well, for this ellipsoid, or not ellipsoid, this model. So I could just say if your model, model 1, what is your MIP that you're looking at? So if sv dispatch group index.x is equal to 1, so the one further behind, I think it should, yeah, it'd be in that order, because it's coming from CPU side. Now we just want to put a super nice printf in there where we say model MIP, and we just write MIP out there. So we take a look at that. It should at least help us figure out, like, right, what MIP is it at? What MIP is it checking? See, that's interesting, right? It's doing it across 32 threads. All across the same, but it's doing it with sort of like scalar values. Is that right? It's the same value for every thread, I think. Yeah, that's scalar as well. So that produces the same result. Yeah, it's all scalar. It's not, doesn't change based on the local index. So yeah, they all exit there, that's fine. Bit crazy, what's going on there? Oh, that's fine. Not really, I don't know. Anyway. Cool, so that's our MIP 7, 6. 7. And as I go back, comes like MIP 6. Yeah, that's right, isn't it? Okay, so here is where it gets cold. So it's about MIP 7 it's kind of checking. And I wish... Oh yeah, but we don't know. Yeah, we should have probably done the check in a different thing, but anyway. Oh, interesting. So yeah, we just actually duplicate this and move it before the is occluded, and then put the drawer in a different one. So the drawer will disappear, but the printing code will still work. Right, so it's still at 7. So if we take a look at that. What sort of thing is it looking at as MIP 7? Right, it's basically this, isn't it? So of course, when you look at a 2x2 and... Oh no, the max zoom is kind of a bit crap. Let's fix that. Excuse me. Max zoom 64. Let's try 128. Why do you even need a max zoom? I don't know. Yeah, so MIP 7. What is that saying? Scaling means... Yeah, zoom in and think. Let's try... Sure what's going on there. Right, I've got 2 places where I've done this, of course. Because it jumped when I sort of moved. I took a down screenshot. Right, so I'm frozen now, that's good. So we go to MIP 7. Yeah, so... Yeah, we really want more zooming capabilities. Let's say 1024, I don't know what else. Right, that'd be better. So it might zoom in a bit too far now, but there you go. Cool, so if we find that thing again and just take a look at those pixels, you can see why it sort of like takes, it's really got to be put behind it before it does disappear. Now, so it seems like it's doing its job right, but we're still getting stuff that's disappearing when we had that sort of full scene. There were things that were kind of disappearing, and maybe that's to do with something else and not the occlusion code then. So is it MIP 7, yeah? So if you take a look at that box that was here, you know, we can gauge what it is. There's no way to maybe not work that out, but yeah, slightly to the right, and so yeah, it's got to pick. It's picking at these pixels, and these are right 12 by 6. So yeah, this is a pixel, so it just happens to pick this sort of 2 by 2 here, where that's the size of it, right? So it'll definitely benefit when it gets smaller and smaller, and I got such a high. But yeah, right. There we go. So the thing that was a bit weird is things were disappearing when they were occluded behind a set of things. It was a bit strange. So maybe these bounding boxes, like... So it was the individual ellipsoids, wasn't it? So let's change up, just change it up a bit now. So I think the model one is fine. So that's interesting. Now let's change it up a bit where we take the bounds of each ellipsoid and see how that behaves in such conditions. Cool. So now we're getting more bounding boxes. Huh. They seem to be behaving kind of okay, right? They are disappearing. I was expecting them to disappear more considering they are smaller, kind of. But regardless, we know why that is because the MIP they end up selecting is... Right, okay, so... Is there anything odd about these bounding boxes? They definitely cover it. The closer it is, the more error there is. Yeah, so as you see this one here. Ooh. Yeah, that's great. It never goes past. Oh. Yeah, okay, this box here is for this ellipsoid here. Okay. Right. There are some odd... We saw this one sort of beam across, but would that create an issue for... It just means it would try to render something that it's not in a tile. It's not in a tile or something, but... Yeah, these are still a bit weird. That just mean I've bin stuff into screen tiles which are not... Yeah, I know why it's happening. But that shouldn't cause any problems with the occlusion culling. So what we can do next, I guess, is we can try this, but select a very specific ellipsoid and just see what's going on. Yeah, that's the next thing then. So we're going to say, right, yeah. So we re-enable the game. So this sort of like 12 by 12 thing. So we're looking at probably ones towards the back. So what's 12 by 12? 144. So we'll literally just pick 144 because we've got these extra ones here. We should get some ones at the back. Wait. Times 2. 144 times 2. So 288, right? So we pick 288. So that'll be... Oh, no, no. 144 on the object. Yeah. There's two ellipsoids in there. Okay. So we only do it for that one. And we only draw the boxes for that one as well. So let's see which one that actually selects and change the value if we don't want to be debugging that one. So that is this one here. So let's see if we can get it to disappear. We saw some disappear. That was, oh, we got it. We got it. So what's going on? So one's at 6, one's at 7. MIP 7, as the terminal is saying. Terminal never lies. So let's look at this region here. We're clearly seeing stuff there, right? It's hard to really see. That looked like it got bigger, didn't it? I think the downsampler is getting bigger. Yeah, it's cropping and being a bit weird, isn't it? So we take that, right, if we change this... Is it getting bigger? Ooh, what's that? Oh, between 5 and 6. 6 is the half MIP. Alright, we found the bug. This is good. So it's 6 and 7. Yeah. Okay, here's the bug. Right. Okay, I know the problem. So, we can delete all this because I'm this confident in it. Right. So, we are using the AMD single pass downsampler, and I support it from their sort of abstraction between GLSL and HLSL, so you can just drop into your code base and, well, just dropping into your code base is a bit of an understatement because there's files everywhere, but when you get it in your code base, you don't have to port their code to the shading language, right? It's just, yeah. So because I got a custom shader compiler for C, a subset of C, I have had to basically port the code from the HLSL version, because that was the closest looking one, to the into this code base, and I've made this sort of include header file code gen things. Here's the example code on how you use it. You basically declare a suffix, a unique suffix, declare a load operation, a store operation, and a reduce operation. And then, so reduce means take 4 pixels and turn it into 1 pixel, right? How do you do it? Do you min it? Do you max it? Do you do a mean average? And then just include the header file, and boom, it generates your new shader where you've got an optimized shader for doing the downsample of that specific thing. So, downsampling a half resolution, so it was about between 720p and, I think we can see it in action how quick it is. Between 720p and 1080p. It is, let's just zoom in on it. It's pretty negligible. So 0.02. So we times that by 4, which is what it would be for a full resolution screen. You're about 0.08 ms. So that's a bit of a ballpark figure of what it would be. So it's pretty quick. depends on how much user code you add here. So why do I know there is a problem in this shader? Because the way we obviously saw the results, right? At MIP 6 it got bigger. Right, when we saw in here at MIP 6 it got bigger. So 5, and then if you look at 6. Well, okay. That one didn't. But we saw it earlier at MIP 6, the sort of thing got a little bit bigger. Maybe we can get a better scene. Let's try that, see what happens. It was something like that. So occlusion texture MIP 5 looks like this, and then I haven't seen anything like that. What's going on? All right, he'll be an example. The ones at the back were disappearing. So 5, these ones back here are disappearing. There you go. See, that is just a bigger block, right? And it happens around the 5, 6 mark. Why is that, right? This should be taking, if you take a look at 4, right? It takes a 2x2 and it should be doing a max op. So that just disappears, right? Then it should be taking a 2x2 or a 2x2 of that, whichever one it is, and doing a max op. But you see that it just got bigger. So that shouldn't be what's happening. Are these even aligned? So how do I know what the problem is? So I think the problem is to do with the way the single pass downsampler works. So it can downsample up to a 4K resolution. The reason why is because it does it in so it does a single compute shader pass. Basically each thread group gets a 64 by 64, and it downsamples 6 MIPS, and then it does another 6 MIPS again. So I think there's a bug to do with after the first 6 MIPS. There's something wrong with the code of ported to make it such that, yeah, there's just something odd going on. Maybe better to do like a color image or something. But I think it's going to do with this. So load MIP 6. I put 6 in there. Maybe it should be 5. That's probably it. It's loading from the wrong MIP. So essentially there's only one load operation which happens from the source image, and then it downsamples. It's quite crazy code. It downsamples 0 to 1 and writes that out, or writes it out at that MIP level, and then it sort of puts it into some LDS memory, and then it does MIP 2 from 1, and then does 3. So it's sort of just doing smaller and smaller regions, something like that. That's my guess. Then when you get to 5, or after you've done 5, you then do 6. And this is going to load from Where's load base? Where's load MIP 6 at? Hang on a minute. Hey, very much. How you doing? How's things? Right, yeah, then at this reduce load 4, when it does 6, it was obviously selecting the wrong MIP, I think. So this is when it does an actual read from memory again. Right, so see if that fixes the problem. Alright. How do we know if it's fixed? Well, we just keep zooming in and out and see if there's no bug anymore. Oh, for crying out loud. I don't know if that was there before. But it's definitely not doing it from far away. Oh. Oh. Oh, that's horrible. Right, you can't really tell because it's a self... It feeds back into itself from the previous frame, so you got to disable that before you check. But yeah, whether the downsample is wrong, but yes. Let's look at 5 and 6 and see what happens. Right, it seems like the transition... What's a 4 in it? Down the scroll thing. Yeah, it seems like that's not a problem there. What about 7? Right, 7's a problem now. Oh my days. What the crap? Right, so there might be an actual... There might be 2 bugs then. Right, there might be 2 bugs. So look at that. Oh, did I not take away 1 from these guys? And so store it in 7 rather than... I think that's true. Store out... I don't know. Let me just figure these out. Do you pass in a hard-coded 2 or something, MIP plus 1? Base MIP is 0. Right, and then your base MIP is after the 60s. Base MIP 8. Right, yeah, I see that. I think I see what the problems are. By the way, do you do any fancy interpolation or averaging of 4 texels? Oh, so in this one, I just take the max operation because, so I've ported this AMD downsampler and I've made this abstraction where I can basically code generate another shader just by including the header file and declaring a couple of functions, which I put a custom suffix on the end of every function. And then I just sort of call that specific downsampler for that specific case. So it means you can choose how you do the loading, choose how you do the storing, choose how you do the reducing. So the averaging or mining or maxing. That's all right, no worries. Oh, interesting. Cool. Cool. How's Shame going? Master Asia, my friend, it's been a good while. How are you doing? Glad to see you. Yes, I think we're storing at the wrong MIP level. Like an absolute melon. Who even does that? So this one's stored... So 5... Yes, you're storing 7. So that needs to be put... You need to put 6s in there, right? And then 8... stores, just double check a minute. +4, 0 +4. That would be, wouldn't it? Because you're passing in next 4. Base MIP is 2. What's going on? How's this working? So next 4. So that will store out to 1. That makes sense. This will store out to 2. That will store out to 2. What do you... Oh, we've got to be careful here. So the base MIPS count 2. So only run out to 2 MIPS. Yeah, so I think you need plus it, so +0 on that one. So 2 plus. Right, that makes sense. That was a big issue. I think it was overall run out to the wrong MIP level. I thought that was right. Oh. So yeah, so effectively in the AMD source code, they were like adding ones and taking away ones in places. I was just getting rid of all of that. Because in the user-defined code, I would have had to do +1s or something for storing. So I just sort of took it away from in the source code. In the internal source code, you don't typically care about. Until it doesn't work, of course. So yeah, 6 is right. That's the 7th one it writes out to. Then this one also stores... Oh, 6 and 7 does it now, eh? Right, so 6, 7... The 5, so it does 6 and 7. So because there's 6 and 7, that's actually a 5. They're painfully wrong. And that stores at 6. This can't be right. Which is 7, which is MIP 7. So then if we've put 6 there, your base MIP then right. Yes, you have to have your 3. Yeah, you have to have 3 MIPs. That makes sense. So this next 4, this has to be starting at 6, right? Because you're doing 6. Hang on a minute. No, it'd be 7, wouldn't it? Oh, what the crap am I doing? So 7, 8, 9, 10. No, sorry, 8. 8, 9, 10, 11, I think. Yes, it's your 12th MIP. So... Oh, wait, hang on a minute. I've been taking away too many ones. These are indices and not for crying out loud. Right, so the ones that I changed then... Yes, these will be 6s and 7s then. But that was 8. So that was definitely wrong there. Oh, these were 7s initially anyway. Right, that's wrong. So these need to be 6s. That'd be 7. Okay, I think we're getting there. So... yeah, that outputs to 1. Doesn't do 0 because 0 is the source image you read anyway. Next 4 will pass in a base of 2. So this adds 1, which it shouldn't do, and these should take away 1. So I'll leave you on 5. 3 plus 2 is 5. Good. Then 6 and 7, we'll do 6s and 7s when they store out. Yep. And then you start on 8. Right. I think that's it. Ho. I'm currently trying to make fragment derivatives less implicit. Right. But I don't want it to become too verbose either, so yeah, trying to figure out a different model. Right. Do you mean like, are you looking at the, what's that one that people are going all crazy about? The superset of HLSL, which just makes the language even more complicated. Slang, that's it. Are you looking at the derivatives in slang? Slang lang. Crying out loud. Shader programming language. Yeah, they have this like compile time derivative thing. It's a bit bananas. I don't really fully understand it, but I don't know. Are you talking about calculate? I mean, yeah, I think I know what you're talking about between like a 2 by 2. If you take a look at their documentation, I just went super verbose on that. So there's something to do with like when you get in there somewhere. Automatic differentiation. I think this is it. Words. Yeah, I think this is it. Doing fine, thanks. Yeah, so it's just too much for my brain right now. So you piece the derivative and stuff. Yeah, have a gander through that. Do fine, thanks. Lots of deadlines at work. The month before the holiday is now a 3-month push to get features ready for console. Awesome. Sounds good. Sounds like super busy. I've not done a release yet, so yeah, I don't know what that feels like, but I can imagine all of the things that you got to try and accomplish in that time. On my spare time, I've been hard at work, set of tools. I've been working on making my own. Working on to make my own in progress games faster. Okay, yeah. So all the prototyping and stuff, most of it is done. Data-driven progression system and data-driven. Right, so it's just a set of like libraries and stuff and that, yeah. For like games, RTS unit groups and driven by a mass ECS system in Unreal. Cool. Configurable building system, RTS units. Awesome. Nice. A bunch more last week's been set up. That would install when I need to speed up now. 8,000 cities for one of my games. Cool. Nice. So you building these sort of prototypes to see if there's one that you want to sort of take to the finish line type of thing? Or you're just having a bit of fun doing some learning? Oh, it's actually differentiable renderer stuff. Yeah, so the way I did my DDX DDY, I don't know if it's gonna be helpful, but I think it's in wave intrinsics. So I just copied what they did in DDX. You said less implicit. So they've got that course. Did you know about the course ones? For crying out loud, it's in my pixel intrinsics. But yeah, so I've got the comments written down because these are like a nightmare to find sometimes. Effectively, I got the DDX one, which does it. I guess that's the implicit one. I'm not sure exactly what your. It will be final course, but you know, in GLSL they've got this. And I think in HLSL they've got it as well, a final course mode, where it sort of like swaps the top one or something like this. Yeah, so fine with high precision using the top or bottom based on where the current thread is. So if the thread is thread 3, it'll swap between 2. Yeah. Whereas the coarse one will do it always on 0 and 1, no matter what. And then like this sort of DDX one will just pick one based on based on external factors. Whatever that means. Maybe detect sampling and and will be suddenly require you to be in a uniform control block to work. Right. Yeah, right. I see, because you've got this thing where you say like right. So where you haven't got any do you know what do you mean by uniform control block? Because you've just got to guarantee that your 2x2 is all active, right? And if the quad isn't active, if the quad has an inactive lane, then you'll get issues. You don't need to have the full 32 thing, right? The spec says otherwise. What, a whole subgroup? Can you point to that? Yeah, derivative group. Yeah, but that's always 2x2, right? Yeah, if you can give me a link to that, because that's always a 2x2. There's no way that's like, because I think in HLSL at least that is defined by a quad. I'm pretty sure. I've never heard of that. We'll be learning something if so. Alright, let's give this a run and see if we fix the problem with the downsampler, which also fixes the problem with the occlusion culling. So let's just have a bit of a play around with this. Get a bit closer. Yeah, these glitches are alright. That's to do with just the near. We're talking about if stuff really disappears. Seems to be alright. So does stuff... Why is it so damn noisy? Anyway, see, I got the occlusion culling thing on. We can ignore the near clip stuff. I cannot see any issues with it for now. Let's just take a look at... Yeah, I can't see any problems going along with it. Let's take a look at the actual depth buffer. So hop this boy out. And we'll... oh, that doesn't look good, does it? So of course it's got no bugs. It's like basically accepting everything. Wait. Was it turned off? Much better. The occlusion color was turned off because I pressed the button. So these weren't showing up. Right, so we are seeing some kind of holes in here. That seems problematic, not gonna lie. Crying out loud. That's also a problem. So we're getting some false feedback still. So MIP 1 to 2 is obviously wrong. Wait, no, that would have been the 4, 3. Two had the wrong one, which means 3 writes out to the wrong one. Is that right? What have you done? Hey, Valigo, how's it going? Thank you so much for the raid, sir. Appreciate it. Welcome, raiders. How are you guys doing? Anyway, the point is, it's too easy to screw this up given the default web silent. Yeah. Right, gotcha. Right, derivative group is defined as a set of invocations collectively processing derivatives, which is at most as large as a single point. Is defined by the client API. Right. So you look into Vulkan. Vulkan Spear V. There's a Vulkan Spear V. What's the terminology for it? Doc. There's like a rules. Yeah, Vulkan environment. It should be in here, maybe. For compute shaders, oh, so linear chords, product of the dimensions of the must be what call a 4. That's something else. There's this derivative group. We're seeing derivative group being mentioned, but it's not saying anything. Maybe based on the primitive it changes. Let's try that. Derivative group must be the equivalent to the quad groups. Helper invocations must spawn such that all quads start with 4 active invocations. This must be somewhere. Am I still using the developer net? Yeah, I'm still using it. I've made some little changes to it. But yeah, it's not... I'm probably working on the game project, right? But any bugs that pop up, I go into it, fix it. Yeah, API agnostic, right. But then, yeah, look into OpenGL as well. I was working on the game's keyboard remapper program in Joy. I had to... Some cursed X11 stuff. Oh my days. Yeah, so the XKB, right? The X11 stuff is always really dangerous because if you change a value with it, it stays like that even if your program crashes. So you have to sort of undo it before it crashes, and it's like that's why things can be broken when games crash in Linux. It's bananas. But yeah, I don't know. This derivative thing looks like it. Yeah, I don't know about it. I wonder whether derivative group is defined. It's weird. There's some spec stuff here. I'm scared to click it and just get completely brain dead by reading it. Right, in addition to some conditions, helper invocations may be terminated when the non-helper invocations in the same derivative group either. Derivative operations. A derivative group in a frame shader is equivalent to the quad scope instance if the quad derivative's KHR execution mode is specified. Right, so that's in the SPIV spec. Oh, it is. That must be in this SPIV spec, right? I don't remember declaring that, to be honest. Quad control KHR reserved. Well, I haven't defined that, I don't think. It's like an extension. It's a I forget what it is. Otherwise, it's equivalent to the primitive scope instance. In a compute shader, it's a quad scope instance. What's the primitive scope instance? So it might be, right? Across the whole... Huh. Right. Let's take a look at my shaders. Oh no, I didn't. That's interesting. What does HLSL do? You can look at it in Godboll, right? Oh, this is something new. Take a look at HLSL. Just do a simple pixel shader, so you just chuck it in there like that. What was that quad thing? Right, what was that again? That was a... Get up there in one of these execution modes. Right, but... Right, dash SPIV. Yeah, origin upper left. I remember doing that in mine as well. You had to, right? Did I skip past the... So does it across the whole primitive in a pixel shader? Right, interesting. I guess it might be better then. Right, good to know. Well, that's something today. Thank you very much. So it's primitive in a pixel... Wow. Now handle the keyboard directly from... Yeah, from EVDev, right? Yeah, I do that too. Well, for my raw inputs. Oh, cool, nice. Unicode. Cool, nice. I love how relationship with Unreal after yesterday, getting the getter and setter binding in the widget class named vector input box stops working and replaced it with a getter and setter that updates only the vector components and the things worked again. Awesome. But what I hate about it is that the other bindings worked as expected for 2 weeks until yesterday and updated the engine source. So no changes to source code. Strange. Sometimes unreal delegate just simply don't work. Right, I've not used those, but yeah, like a delegate, it's like the C# one, it's like a callback, right? Maybe when you use vertex attributes, maybe they want to use vertex attributes directly in some cases and do optimizations for that. Interesting. Right. Because they know it's, yeah. Perhaps. That's true. Perhaps they do that. It's mad. Maybe they could do that. Yeah. That's going to make sense. Right, so looking at MIP2 had an invalid MIP written in there for some reason. It was like a smaller one. I don't know. We'll look at it again. Yeah, fancy call that basically Unreal's version of std function. Oh, good old std function. It's so dangerous doing closures in C++. If you don't take that reference, your object is getting copied. Right. Right, so 1 was alright. 2 is when it failed. Well, 2 wrote out, sorry, right, again. 2 wrote out okay, but 3 went on to 2. Alright, why is that? 3 is here. What are you doing? Hmm? 2 plus 0. Yes, that's stores. Oh, for crying out loud. They're 0 based from MIP1. Ah, my brain. Right, right, let's do it again. So these are 1s, these are 2s. So these do need to be... So these do need to be +1. And then the problem was in 6 and 7. So that writes out into 6. So 6 and 7, which is actually 7 and 8, for crying out loud, these names. So that's actually 7 and 8. So that needs to be 7, 8. Which it was, right? That was 7, 8 before, wasn't it? So what have I changed? And then 8 plus 1, which will get you obviously 9, 10. I think I miscounted somewhere, because that's 11, 12, isn't it? How are you storing? Oh, my mistake. Yeah, these are 1s, these are not 2s. Oh no, it's in a store. Store emit for 2s. So those were okay, I remember that, but then it broke. MIP2 wasn't wrong. What was wrong was 3, apparently. How could 3 have been wrong, but then MIP? These things. Alright, let's run that and see what it looks like. Yes, these are disappearing here, so we look at that there. Occlusion. Took these down sample. That's fine. That's fine as well. 5 is okay. 6 is where there's a problem, right? Right, is it? Yeah, so that kind of got bigger. Now I'm thinking, is it because if you look at the MIP dims, that's an odd number. And it's been even the whole time. So it might be because there was an odd number about it. So 5 was odd, so when you divided it, it caused you to lose. So it's not about sampling from the wrong one. I think it's to do with the whole the way it's picking the pixels out, maybe. Right, can I git diff this? Yes, that seems like a very... Did we change any of it? Right, so we did change it to sample from a different one there, but is that true? So we loaded from MIP6. Right, I just need to undo the whole file, basically. Alright, so nothing seems to be... Maybe nothing is wrong with this. Yeah, because that's an index. So what the issue is probably to do with then is the fact that it's an odd number. And they did mention this, but I was like, let's see if there's any problems with that. And brushed it under the rug. So it says you might need to round it up to a 64 or something. So there's a limitations section, isn't there? Just got to find it. Limitations. So single pass downsampler only supports 2x2 kernel min max for mini operations each MIP level. No, it don't. Not with my changes. In the case of an odd dimension, the last row or column will be omitted. The resolution of 7x4 produces a MIP level of 3x2, with the values from the 6x4 region in the 7th row is ignored. I thought that was okay, but what ended up happening is that something weird is going on. Maybe. We can look at it again. This problem can be solved by padding out the input texture into a dimension of power of 2. An alternative solution is to pad the input texture to multiple 64 and handle the odd cases manually for MIPs that are computed by the remaining thread groups. So I think what we can try is let's just make it power of 2 and just see if that solves the problem. I don't think we have any issues with that. in the rest of the code. So we find the occlusion calculation here. When we generate this actual dims here, we just simply round it up to the nearest power of 2, simply. Round up power of 2, and I'll just do this. We'll just see what it looks like. And that way you'll never get an odd number. We'll see if that's a problem. Just make some really ugly code in the meantime. Alright, so don't see any problems there. Let's take a look at it. Did take more tries, but right, so round up to the nearest power of 2, and then we do this sort of thing. It would be kind of annoying if we had to round up to the nearest power of 2, though. I would not be happy with that. So 5, then 6. Right, that did compress down nicely there. We saw it, right? It just yeah, only got rid of stuff. It never sort of like made it bigger. So that's fine. I'm interested to see if we mess around with it a bit more, if we do come across any of those problems. It might be the odd dimension thing, in which would be very, very annoying. Well, it might be annoying, right? Or what was that? I think, yeah, we ignore the close-up bugs. They're not a problem. So it seems like we're not seeing any of them disappear, which is good. Alright. So it seems like it's the odd number thing. So is there a bug? Because the way I read... Yeah, I'm not seeing any disappear. Okay. So the way that I read this limitation is that it just omits the border of the odd number, right? Which would be fine. Would it? No, it wouldn't. Because... yeah, I don't think it will be fine. Yeah, I don't think it will. So we might have to just round up to nearest power of 2 because of that problem. So if we think about it, if you round up to the power of 2, that whole texture technically represents the whole screen, meaning that it could grow by... the value could grow by... the pixel in a sense is growing by half a pixel or something like this of the previous MIP. Something like that. I'm just, you know, spitballing the maths here. So I think that's what's going on. So we'll just keep with this. Otherwise we've got to try and... yeah, so actual occlusion dims. Actually, actual occlusion dims. Let's drop that in there. So I think that's it. Okay. So we'll put a comment in here just to say round up nearest power of 2 such that the downsample will not, so it's growing, the pixel represents, when you go from an odd, when you downsample an odd number, it will discard the edge, meaning that the pixels will actually grow unevenly between the MIP levels or something like this. Yeah, does it mention that in the occlusion kind of thing, power of 2? But have you configured Halo Glass? How's it going? It looks to be the same as NeoVim without select annoyance. No, it still works. I haven't changed it for that. You just jump words and it will. Yeah, just do the selection. So yeah, it completely did the whole config from scratch again. Yeah, my own custom keyboard layout basically, because it's in Colmac and it's in the terminal, so things don't map very nicely. Start end of selection. Oh, that was just me. So highlighting the next word, highlight the previous word, highlight the next word, highlight the previous word. There is a button where you can get it to change between back and forth between the selections though. There's a button for that. Let me try and figure it out. So I've mapped mine to this, but it's called I forgot, where's my config? Flip selections, that's the command. So yes, flip selections. Yeah, give that a go. That's alright, no worries. Round up to the nearest power of 2 such that the downsample will not, such that when a MIP, such that no MIP will be an odd number except for the last MIP, the final MIP. If we have an oddly sized MIP. Okay, let me rephrase this. No MIP's dimensions will be an odd number. Round up the nearest power of 2 such that no MIP's dimensions will be an odd number except for the final MIP. If we have an oddly sized MIP, the following MIP level will represent more area of the screen, isn't it? Will represent more area of the screen than it would have since the border of the previous MIP. Since the border of the oddly sized MIP will be discarded, will be ignored. Yeah, that's definitely what the problem is. That's good. Cool. That's awesome. So we're in a really good place right now. We've got the super sampled anti-aliasing, multi-sampled anti-aliasing, ray trace anti-aliasing shaders, all doing the sorting in the pixel shader. We haven't tested transparency yet. That's something to come for in the future, but they're rendering in the correct front to back order now. We can rely on the tile binning front to back order because I think spheres work fine when I thought about it, but then they don't actually work good for ellipsoids. So we've sorted out that. We've sorted out the occlusion culling now. It would be cool to do this sort of heat map at some point. I'll keep that in my brain. So this got done. The single pass down sampler this month. We've done the occlusion buffer now. We've fixed the Z fighting thing. So there's transparency that we do need to test. And there's also testing a high number of model instances just to see about performance and stuff, to see how things scale. Yes. So, and then probably some sort of like fade out the smaller ellipsoids. So you could probably try that out as well. So these would be interesting. So next stream, which will be on Tuesday, I guess we'll get a bunch of different model types in, because we've just got one. It's this weird one. You know, we've got like 4 other weird ones as well. Just into the basic programmer art, because I don't have any ways to make models without just hard coding it in code. And then I guess we can look at a bit of transparency as well after that. You just put a ton of models on the scene and just see how it behaves with the occlusion culling and stuff like that. See if there's something we need to do on top of this. And maybe we'll need to render out that heat map thing. Yeah, maybe we'll need that heat map thing actually then, you know. Yeah, then we can, I guess on Thursday we could look into probably transparency and maybe this thing here if it's not too bad. And then Sunday next stream we'll focus on the actual rendering to HDR texture. So by that I mean like when you make that when we use those ray tracers, we output to 16 bits per channel texture. And then at the end of, before we send out to the screen, if it's not HDR screen, you tone map it. So we'll just probably use a pretty common tone mapper. And then the following week after that, we'll probably work, yeah, so I guess we've got, and then the final week, or we'll probably start on Bloom before the final week, so I think we should be able to get this all done this month, which would be pretty sweet. We'll see. See how it goes. Right, so yeah. Let's find someone to raid then in the meantime. If you want to join the Discord, guys, feel free to come and hang out in the meantime and have a chat. There's also ways if you want to get access to the code you support via Ko-Fi or Twitch. Ko-Fi is much better for me. You know, Twitch takes quite a lot of the cut. Ko-Fi takes less. And you get access to the code as a bit of a thank you. And yeah, appreciate everyone who supports me so far. Appreciate you guys. And let's find who is online. Anyone got any suggestions for people? There's not too many game engine devs these days. At least we're few and spread apart, I guess, across. Can I search for a C? C tag. No. There's a CPP. Right, this one will do. Nathan. It is. Alright. Have a good start to your work week, guys. Ah, is Zorchenheimer on? Ah, interesting. I'll raid him next time. You'll see him. I need to follow him, actually. Yeah, it's alright, it's alright. No worries. Right, have a good start to your work week, guys. See you in the next one. Bye-bye. Thank you, thank you.